In this video, we're going to cover the symmetry of parabolas. In other words, we're going to understand that parabolas are symmetrical, and we're going to use that information to solve problems. So, I've got a table for a quadratic function w of x here, and we don't know what w of x looks like exactly, but we know a bunch of points on the graph. And so, first off, I can plot some of these points if I want to, and I'll plot a few of them. 1, 2, 3, 4, 5, 6. So there's 1, 7, and then we've got 2, 0, and then 3, negative 1, 2, 3, 4, 3, negative 5, 4, 6, 7, oops, 4, negative 8. So I'm just plotting a few of these points from the table. 5, negative 9, and then it gives us 6, negative 8, and 7, negative 5. So we can kind of see the shape that, if I could draw the perfect curve here, we could see the shape that our parabola is kind of taking down here, down to the vertex, and then back up. Now, first it asks us to find the zeros of w of x. Now, we know the zeros are where the function does that, where the function equals 0. So if I look, there's one of the zeros right now. It's the value of x when y is 0. The zeros, remember, are also the same thing as the roots. They're also the same thing as the x-intercept. So if I were to come over here, I can see that 2 on my graph for the x-intercept. So we know that one of our roots is 2. Now the thing is, there's going to be another root. We just got to figure out where exactly it is. I don't know. I don't know if it's over, if it's there, if it's there, if it's there. It's somewhere where this graph comes back up and crosses the x-axis. Now, here's your best way to do this, and here's where we use the information that we know about our parabola being symmetrical. I can tell from my graph, or I can tell from my table where the vertex is. If I know where the vertex is, I know where the axis of symmetry is, which in this case is at x equals 5. That's our axis of symmetry, x equals 5, and once again we see it in our table right there, where that is the vertex. If I'm looking at my graph, I see that from that point, from that 0, it's 3 units over to my axis of symmetry. Therefore, if I go 3 more units over, I'm going to get to my other 0. And so if I were to keep this graph going, it would look something like this, with that point right there being my other 0, because it's going to be equidistant to the axis of symmetry. So if that first 0 is at 2, then it's 3, 4, 5, 6, 7, 8. The other 0 is at 8, and that's what we found from our graph. If you were to look at the pattern in your table, you could have seen it there as well. If we hit the vertex there, and that's 3 points away from our first 0, then if I go 3 more points away, that would give me that other 0. So we can tell from the table or from the graph. Vertex, same thing. We can tell from the table it's at 5, negative 9. I can also tell by looking at the graph it's at 5, negative 9. Assuming there is no vertical stretch, we're going to write the function of w of x. Now, here's where it gets interesting. The easiest way to do this is from our factored form. We know that if our zeros are a and b, here's the factored form of the function. But we know what our zeros are. Our zeros are 2 and 8. Boom. So there's your factored form of your function. Since our parabola opens upward and has a vertex for a minimum, our leading coefficient is going to be positive. If it had a reflection, it might be negative, but we're not dealing with that here. And then lastly, it says we want to convert this equation to standard form. So I'm going to do w of x equals x minus 2 times x minus 8. And to convert to standard form, we're just going to multiply this back together. I'm going to get x squared minus 8x minus 2x plus 16. And once I combine like terms, I should get this down here at the bottom. Okay. Now, this problem had us do a lot of stuff other than use the symmetry of our parabola, but we need to really just be able to kind of synthesize and combine all the knowledge we have about parabolas to answer questions like this. But the main idea is whenever it gives you a table and we're asked to do a bunch of stuff based on the table, that's when you got to come over to the graph and graph what you know. Because then we can find out, well, if I know one point in the axis of symmetry, how do I find that other point that we found? And just kind of play with it and use your reasoning is going to be the best way to get through this type of problem.